Okay, so today we are going to be looking at how do we create a difference of two proportion significance test, and we are using the context, which grade is more likely to go to prom. So as you read this, notice it says that we have a random sample of 50 juniors, 28 of which are planning on going to prom, and then we have a random sample of 45 seniors, 29 of which are going to prom. So right away, I'm going to just define my P1 and P2. I'm going to say that P1, ooh, that's tiny. I'm going to say P1 is juniors. And so P hat 1 is going to be 28 out of 50. And P2 is seniors. So P hat 2 will be 29 out of 45. Okay, so for my parameter, as I state the parameter, it's really important that here I take the time to define the direction of my difference. So I'm going to start with P1 minus P2 so that I've defined direction. And this is the true difference in proportion of juniors and seniors going to prom or planning to go to prom. Again, juniors minus seniors. For our null hypothesis, always when we have two samples in two different populations, our null is going to be that P1 minus P2 equals 0. And essentially we're saying that P1 and P2 are equal to each other. The alternative hypothesis, this comes from the problem. In the problem we're asked, is there convincing evidence that a higher proportion of seniors are going to prom? Well, if seniors are higher, remember, seniors we've defined as P2. So if P2 is greater than P1, what's going to happen when I subtract P1 minus P2? It'll be a negative number. So our alternative is that P1 minus P2 is less than 0. It's a negative value. The statistic that we are going to use is the difference of the P hats. So P hat 1 minus P hat 2. That is 28 over 50 minus 29 over 45 equal to negative 0.08. And our significance level, that also comes straight from the problem. It tells us to use the 5% significance level, so as a decimal 0.05. Now, as I'm getting into naming, or to the plan phase, which starts with naming the procedure. First off, right now we have two samples, so I'll label it as a two sample Z test. Remember, we are doing tests now, significant tests, for P1 minus P2. And now we're going to check our conditions. The first one being random, which we know from the problem, it states that we have random samples taken. The second one is the 10% condition, and so the 10% condition is that our sample sizes are less than 10% of the population. So 50 is less than 10% of all juniors, and 45 is less than 10% of all seniors. And then the last one is large counts. Now, when we do the large counts, typically we are, and always we're doing n times p and n times 1 minus p, but we get that p value from our null hypothesis, because remember, it's the null hypothesis that we are assuming to be true. The problem is, though, that this null hypothesis does not tell me what P1 and P2 are. It just tells me that together they have a difference of 0, essentially that they are exactly equal to each other, but I don't know what they are. They could both be 0.2, they could both be 0.3, 0.4, 0.5, or some other value. So in order to do this, we're doing something new. We have to find P hat combined. So P hat combined is equal to x1 plus x2 over n1 plus n2. And essentially, it is taking both populations and just finding the overall proportion of all people going to prom in this context. So that would equal 28 plus 29 over 45 plus 50, and we have a p hat combined of 0.6. Now, this is what we're going to use for both P1 and P2. So for large counts, instead of N1 P1, now it's going to be N1 P hat combined greater than or equal to 10, and N1 1 minus P hat combined greater than or equal to 10. So I'm going to do 50 times 0.6 greater than or equal to 10, 50 times 1 minus 0.6 greater than or equal to 10, and I do the same thing for N2. For the seniors, 45 times 0.6 greater than or equal to 10, and 45 times 1 minus 0.6 greater than or equal to 10. All right, now in the do section, we are going to use the normal distribution to answer the problem. Well, to use the normal distribution, I need to start by finding the mean. On our formula sheets, we are reminded that the mean of p hat 1 minus p hat 2 for a sampling distribution is equal to p1 minus p2. And remember, in order to find this, I want to go back to the null hypothesis being true. Well, the null hypothesis tells me that p1 minus p2 is equal to 0. So right there, it basically tells me that the mean is 0. For standard deviation, well, typically when we have a difference of two proportions, we use the standard deviation equation on our formula sheet, where we do the square root of P1, 1 minus P1 over N1, plus P2, 1 minus P2 over N2. But remember, we don't know P1 and P2. Rather, we have P hat combined. And so that's what we're going to use. So our standard deviation is now going to be, equal to P hat combined times 1 minus P hat combined over N1 plus, so we still do both N1 and N2 separate. So when I plug in here, that is the square root of 0.6 times 1 minus 0.6 over 50 plus 0.6 times 1 minus 0.6 over 45 equals 0.1. Now I'm ready to draw my picture. So for our picture, we're going to label our curve n of the mean, which is 0, and standard deviation 0.1. And I'm going to label the value that I want to test, and that is our statistic, right? We want to use the statistic here. So I'm going to label where negative 0.08 is and shade below, because we believe that this difference of proportions is going to be less than 0. Now for my general formula, everything here basically follows the same. Our general formula is test statistic equals statistic minus parameter over standard deviation. My specific formula, z equals p hat 1 minus p hat 2 minus p1 minus p2 over the standard deviation, which is p hat combined times 1 minus p hat combined over n1 plus p hat combined times 1 minus p hat combined over n2. So as I plug all of these things in, my z is negative 0.08 minus 0 over 0.1. And so we get that our z score is negative 0.8. All right, for the test statistic, that is our z score, so z equals negative 0.8. And then from there, we can use our z table to find our z value. our p-value, which is 0.2119. And now I'm ready to conclude. So for concluding, remember we interpret P and we write the conclusion. So starting with the interpretation of P, assuming the null, which is that P1 minus P2 equals 0, there is a 0.2119 probability of getting P hat 1 minus P hat 2 equal to negative 0.08 or lower, right, the direction we shaded, purely by chance. The second part of this, our conclusion, because 0.2119 is greater than 0.05, we fail to reject the null. All right, null. And do not have convincing evidence that a higher proportion of seniors are going to prom. All right, so for the important ideas for this, we're going to just go through what we do for state, plan, do, conclude, starting with state. So we're going to first state our direction, P1 minus P2, and label that this is the true difference in proportions. We are also going to state our null hypothesis, which is always that P1 minus P2 equals 0. And then our alternative hypothesis, P1 minus P2, can either be less than, greater than, or just not equal to 0. Those are our three options. For the plan phase, we're going to start by naming, which for these two samples is a two-sample z-test for P1 minus P2. And then we're going to check conditions. And remember to use the p hat combined for large counts. All right, then the do. Our z-score formula is p hat 1 minus p hat 2 minus p1 minus p2 over the standard deviation. Again, we use the p hat combined. So p hat combined times 1 minus p hat combined over n1 plus p hat combined times 1 minus p hat combined over n2. Remember, p hat combined is found by taking the two proportions or the two samples and combining them to 1. So x1 plus x2 over n1 plus n2. And lastly, we conclude. And when I conclude, remember that we test our p-value. If it is less than the significance level, then we reject the null. And we have convincing evidence. For the alternative. If that p-value is greater than our significance level, that is when we fail to reject the null and do not have convincing evidence. remember to also interpret your P. So try this, check your understanding, and if you have any questions, let me know.